Checkout calls payments. In code, it resembles a local function. But payments runs in another process, so the operating system, network, and another machine enter the path. The call can be delayed, duplicated, rejected, or lost. A local-looking call has become a distributed systems problem. Every service asks the same transport questions: how long to wait, when to retry, which instance is healthy, who is calling, and whether to encrypt. Put those answers inside every application, and each language, team, and release carries another copy. Consistency now depends on updating every copy. Business logic and transport policy change for different reasons. Checkout should understand carts and prices, not certificates or retry budgets. Move shared communication concerns to a consistent boundary around the application. The application expresses intent, the boundary handles transport. That boundary is the service mesh. The components that handle service traffic form the data plane. A sidecar places a proxy beside each workload. An ambient design can intercept in a shared node layer. Either way, outbound and inbound requests cross the mesh before reaching the network or application. Proxies need identities, destinations, certificates, routes, and policy. A control plane watches the environment, converts high-level rules into configuration, then distributes it to the data plane. It programs behavior but does not normally carry requests. Existing proxies can keep their last accepted configuration when updates pause. Encryption hides traffic, but identity proves who is connected. Each proxy presents a workload identity. Both ends verify one another, establish an encrypted channel, then authorize that identity. Mutual TLS replaces assumptions based only on IP addresses with cryptographic proof of the workloads at both ends. A programmable boundary can route without application changes. 90% of requests can stay on version 1, while 10% test version 2. Unhealthy destinations can be removed, and the canary can be closed instantly. Progressive delivery becomes observable and reversible, provided routing policy remains understandable. The mesh can enforce timeouts, retries, circuit breaking, and load balancing. These controls help only when they are bounded. Retries across several layers can multiply load while a dependency is already failing. Good policy limits total time and retry budget, then opens the circuit and fails clearly. Every proxied request crosses the same measurement point. The mesh can record latency, status, request volume, identity, traces, and access logs consistently across languages. This explains communication, not business intent. The mesh can report an error. Only application telemetry can explain which business rule produced it. A service mesh is an architecture, not one mandatory proxy shape. Sidecars provide isolation beside every workload but consume resources. Shared or ambient layers move common transport functions to node-level components. The implementation changes, the principle remains. Transport behavior lives outside business code. A mesh adds processes, certificates, policies, upgrades, metrics, latency, and new failure modes. Debugging spans the application, network, data plane, and control plane. For a few simple services, libraries or a gateway may be enough. Adopt a mesh for a repeated cross-service problem, not architectural fashion. Keep the model. Applications create business requests. The data plane carries them. The control plane distributes rules. Identity secures endpoints. Policy chooses routes and bounds failure. And telemetry describes outcomes. A mesh moves shared network complexity into one system that can be controlled deliberately.